Meet Maya. She's a 7th grader who just signed up to help build the sets for her school play. The drama teacher hands her a blueprint for a triangular prism-shaped prop, basically a 3D tent shape. Maya stares at it and thinks, how do I even figure out how much space this takes up or how much material I need to cover it? That's exactly what we're going to find out today. Let's dive in. Before we crunch any numbers, let's make sure we know exactly what we're working with. A triangular prism is a 3D shape that has 2 triangle faces on the ends, we call those the bases, and 3 rectangle faces connecting them on the sides. Think of a Toblerone chocolate bar or a camping tent. Maya's prop looks just like that. The triangular prism has 5 faces total, 2 triangles and 3 rectangles. Got it? Great. Now let's talk about its parts. Okay, here's the big idea for volume. Volume measures how much space a 3D shape takes up, like how much air fits inside Maya's prop. The formula is volume equals the area of the triangular base times the length of the prism, and the area of a triangle is 1/2 times base times height. So putting it all together, volume equals 1/2 times b times h times L. Think of it this way. You're stacking that triangle shape over and over down the entire length. That's your volume. Now, surface area is different. It answers the question, how much material do you need to cover the outside of the shape? Maya needs to know this so she can buy the right amount of fabric for her prop. Surface area equals the sum of all the faces. That means 2 triangles plus 3 rectangles. The formula is surface area equals 2 times 1/2 BH plus the perimeter of the triangle times the length. Let's break that down piece by piece so it's crystal clear. Let's make this super clear. The surface area has 2 parts. Part 1, the 2 triangular bases. Their combined area is just b times h, because 2 halves make a whole. Part 2, the 3 rectangular side faces. Each rectangle has a width equal to one side of the triangle and a height equal to L, the length of the prism. So you add up all 3 sides of the triangle, that's the perimeter, and multiply by L. Add both parts together, and you've got your total surface area. Maya's starting to see it now. Let's solve Maya's first problem together. The triangular base has a base of 6 centimeters and a height of 4 centimeters. The length of the prism is 10 centimeters. Using our formula, V equals 1/2 times B times H times L. Plug in the numbers. V equals 1/2 times 6 times 4 times 10. First, 1/2 times 6 equals 3. Then 3 times 4 equals 12. Finally, 12 times 10 equals 120. The volume is 120 cubic centimeters. Maya pumps her fist. She just figured out how much space her prop takes up. Maya's second prop. The triangle base is 5 centimeters, height is 8 centimeters, and the prism length is 12 centimeters. Volume equals 1/2 times 5 times 8 times 12. Start with 1/2 times 5. That's 2.5. Then 2.5 times 8 equals 20. Finally, 20 times 12 equals 240. The volume is 240 cubic centimeters. Alternatively, multiply in any order. 1/2 times 8 is 4, then 4 times 5 is 20, then 20 times 12 is 240. Same answer. Maya is on a roll now. Now Maya needs to know how much fabric to buy. That means surface area time. Here's a pro tip for staying organized. Break the surface area into parts and label everything. Draw your triangular face and label all 3 sides. Call them A, B, and C. Mark the base B and height H for the triangle area. Mark the length L of the prism. Now list out each face, 2 triangles and 3 rectangles with widths A, B, and C. Once you have all the pieces listed, plug them in and add. Organization is Maya's secret weapon here. Here's Maya's surface area problem. The triangular base has sides of 3 centimeters, 4 centimeters, and 5 centimeters. That's a right triangle. The height of the triangle is 3 centimeters. Wait, Actually, for a 3, 4, 5 right triangle with legs 3 and 4, the height from the right angle to the hypotenuse approach is complex. So let's use the two legs as base and height directly. Base equals 3 centimeters, height equals 4 centimeters. Length of prism is 10 centimeters. Let's find the area of the two triangular bases first. Area of one triangle equals 1/2 times 3 times 4 equals 1/2 times 12 equals 6. Two triangles, 2 times 6 equals 12 square centimeters. Now let's find the areas of the three rectangular side faces. Each rectangle has a length of 10 centimeters and widths equal to each side of the triangle, 3 centimeters, 4 centimeters, and 5 centimeters. Rectangle 1, 3 times 10 equals 30 square centimeters. Rectangle 2, 4 times 10 equals 40 square centimeters. Rectangle 3, 5 times 10 equals 50 square centimeters. Now add all three rectangles. 30 plus 40 equals 70, and 70 plus 50 equals 120 square centimeters total for the rectangular faces. We're almost there. One more step. We've got both parts. Now let's put it all together. The two triangular bases gave us 12 square centimeters. The three rectangular faces gave us 120 square centimeters. Total surface area equals 12 plus 120. Let's add. 12 plus 120 equals 132 square centimeters. That's Maya's answer. She needs 132 square centimeters of fabric to cover her prop. Maya does a happy dance. She solved the whole thing. From the triangular bases to the rectangular sides, she nailed every part of the surface area. Let's do one final practice problem before we wrap up. A triangular prism has a triangle base of 8 centimeters, triangle height of 3 centimeters, and a prism length of 7 centimeters. Volume equals 1/2 times 8 times 3 times 7. Let's go step by step. 1/2 times 8 equals 4. Then 4 times 3 equals 12. Finally, 12 times 7 equals 84. The volume is 84 cubic centimeters. See how much faster that felt? You're building serious math skills right now. Parents, this is a great one to quiz your kids on tonight. Remember when Maya stared at that blueprint with no idea what to do? Look at her now. She can find volume and surface area like a pro. Let's recap the key formulas. For volume, 1/2 times B times H times L. For surface area, B times H for the two triangles, plus the perimeter of the triangle times L for the three rectangles. The secret is to break it into parts and tackle each one. You've got these tools now. Triangular prisms have no more secrets. Keep practicing, and you'll be the math MVP of your class. You've totally